And I'm just going to start with the introducing the session. Thank you for coming to the session, which has the title of Which IDAC is Right for Me. And thanks to all the IDAC groups that are here and also users. So the point of this session is really that since a lot of Rubin analysis depends on significant compute resources, which can be challenging to come by. The Rubin in-kind program provides one way for the user community to get access to those resources at the expense of having a distributed set of computing centers. You have to get data and subsets of the data to those places. And so this session is really about trying to pair up what the computing centers are providing with what the users need to do their Rubin studies. Mostly I'm going to give a quick introduction, and then we're going to hear from some of the computing center providers. We're going to hear from some of the use cases, and we'll have a discussion on how we improve that pair. Okay. So just the reminder slides that you've seen before about the code of conduct, COVID-19 protocols, which still exist, and social batteries to respect those. And we do have a couple of remote presentations. So we need to be able to hear people on Zoom, but when you're not speaking, to please mute, and to use the Slack channel that we have for this to ask questions as well as have discussions. So I just ran through this quickly. We're going to do some introduction, around half an hour of pitches from the data centers themselves, some pitches of science use cases, and then the discussion. Okay. Just to get into a little terminology, so this is about computing resources to do analysis with Rubin data. There are many different types of computing resources, and it can be a confusing sort of set of terms. So I just list some of them here. So we have data access centers set up by Rubin to provide access to the data. There's one in the US, operated in the cloud, and a Chilean data access center as well. And IDAC, which is an acronym that will be thrown around a lot in this particular session, is an independent data access center. And these are often contributed through the Rubin in-kind program, although we do have a growing number of independent data access centers in the US that are not contributed through the in-kinds. The term scientific processing center is also sometimes used. These are places that are mainly focused on giving compute resources without a lot of data access or storage. And we basically have one example of that. And given their ambitions, they may actually start hosting some data as well, which would really make them an IDAC. We have light versus full IDACs. This is simply a difference in the scale of Rubin data that's hosted, scale of hardware resources, and requirements on the software interfaces. And these terms are described in this tech note RTN 003. And then we have data facilities, which are the places where the Rubin data processing occurs. So one is here at Slack in the US, and the UK and France, CCIN2P3 are also contributing to data processing. So with that out of the way, what IDACs deliver, and I'm using the acronym, but it's a little bit overloaded, so it includes the scientific processing centers as well. Our resources in terms of compute and storage and access to data over and above that which is already given through the Rubin program. And we want to enhance the amount of compute and storage that people can have access to. their science. They should be easily accessed by any data rights holder. Does not mean that all Rubin users get accounts on every IDAC. That's something that we will talk about. We encourage them to be focused on particular science opportunities and collaborations, because this is a way to make sure that we're getting good use of those resources and getting science out, which is really the main focus of this. It can also include support to other non-LSST data sets. This is important for some science use cases, I think, as you'll see. And we also have IDACs that are providing support for publicly shareable LSST data. Canada is an example of this. So Rubin data goes public after 2 years, but that does not mean that any public member gets an account at the U.S. Data Access Center. So this is a way to deliver that data to them. So I want to give an update on a few developments in the realm of IDAC. So IDACs were intended to be ready for operation with the release of DR1. That's now 2 years away. There's a lot of preparation that goes into being ready for that. One of those data transfers. So we've done with many IDACs tests of transferring DP1 data, which was a 3.5 terabyte data set, to various IDACs for testing purposes. And we're now proceeding, I think, shortly with transferring DP2, which was just released yesterday. And the spreadsheet just we used for planning purposes on what data sets would be selected by which IDACs and whether they were ready to receive it. So eventually, I think fairly soon, this will all be green, which means that everybody's ready to receive data. Another development, so the user community has been looking for ways to get an overview of what IDACs provide in terms of resources. So we've created a dashboard based on a spreadsheet that the IDACs filled in on info on what they were providing. It shows a map of where the IDACs are, what data products they will be hosting, whether or not they have GPUs in their plans, and then a card for each IDAC that can be updated by the IDAC providers themselves to advertise what's available to the user community. And this is still sort of in beta, in development, but it's our plan to refine this to make it a useful tool for the user community. Another development is, since, as I mentioned, we're trying to pair user communities with the computing resources to make sure that we're making efficient use of these contributions, is we have an agreement now that we're testing between the Solar System Science Collaboration and the Croatian Scientific Processing Center / IDAC to basically guarantee some portion of those computing resources for the Solar System Science Collaboration. What this gives us and the Croatian IDAC is basically commitment from the Solar System Science Collaboration to provide some level of onboarding and training for its users. So you have well-informed users using the resources, and it also guarantees that the resources are being used for good science. The plan is to review these the agreements like this annually, so we're making sure that good science is coming out. And it also does not preclude Croatia, in this case, from forming relationships with other science collaborations. They're in discussion with TVS and STARS, Milky Way, and Local Volume as well. And these can be reviewed, but I think this is an example of a successful pairing between science use cases and contributed computing resources. And overall, we just want to make sure that these computing resources are being used well. So with that, we're going to dive into the pitches from IDACs themselves. So each of the IDACs, often they bring something unique, either in terms of data or in interfaces or in the kinds of resources that they're offering, which is information that you'd like to know when deciding for your science which IDACs you'd like to begin to approach to start forming a relationship. So first up is Canada. Here is the clicker. We're trying to do these pitches in roughly 5 minutes per session. Okay.
So my name is Stephen Gwynn. I am the lead of the IDAC for Canada, and I'm just going to talk to you briefly about it. So just a bit of background, the way we're going to be delivering compute resources is through the Campfire Science Platform, which is a little bit like the Rubin Science Platform, but there are a few sort of important differences. First off is we've been in operation since 2019. If you're in Canada, you would not need this introductory slide because pretty much everybody knows about it. And at a recent CASCA, which is the code of the AAS, I sort of asked the audience who here uses it. Put your hand up, and most people put their hand up. So we're kind of ubiquitous within Canada. We're internationally famous in Canada. So what Campfire provides is notebooks and virtual desktops, and which just looks like an old timey X-Windows session, except each X-term is actually running on a different container. So it provides access to a fair number of resources that way. Each session, you can have up to 3 of them with up to 192 gig of RAM, 16 cores. We do have some GPUs. We have an extensive amount of user storage so that people can come in. By default, we give them a relatively small amount, 200 gigabytes. I can't remember what it was. But if you come in and say, I have a project that's going to require 10 terabytes, we go, okay, no problem, we'll set that aside for you and your project. And then we also provide, in addition to interactive sessions, we provide batch processing through headless jobs where you can submit jobs to a queue. When it's put unlimited in quotation marks, what that actually means is when no one else is using them using interactive sessions, your batch job will run in the background and run that way. We have additional data sets of the CDC besides just LSST. So the biggest of which is going to be SKA. But right now we have the Euclid DR1 is sitting on CDC hard drive. We have Unions, which is a survey in the north that's UGRIZ, much like LSST is. It's bigger than DP2, but smaller than DR1, so it's roughly intermediate in log space between those two. And then, of course, we have copies of the James Webb Telescope, Hubble, and there's a possibility we may incorporate Roman into our holdings. So what have we committed to deliver in terms of compute resources? So 3,000 cores with associated scratch space and sizable amounts of memory. 2.7 petabytes of storage for the LSST co-edit images, 100 terabytes of database storage for the LSST object table, plus various smaller tables, and then 2 petabytes of user storage to store user-generated data products. And that's actually times 2, where we're going to deliver one of those in time for DR1 for you Rubin database holders, and then when DR1 becomes public, at this point, 2030, I guess, we'll provide a second set of resources to the larger astronomical community for anybody, not necessarily data right holders, to access Rubin data. So there's a giant asterisk here to all of this, and that is because the initial size estimates for DR1s were slightly overestimated. So the coads turn out not to be 2.7 petabytes of data, but actually 0.7 petabytes. So we actually have a bit more disk space than we originally planned. And then we also have the object table for DR1 has shrunk from an estimated 100 terabytes down to about, yes, 1 minute? Oh, jeez. So anyhow, the And then also there was a request from Knut say, hey, could you change some of these cores to GPUs because no one else is providing them? And we're like, heck yes, but it has to be done in a cost neutral manner. This was suggested last year. If we had acted on that instantly, we'd have a whole bunch of GPUs for real cheap. It would be very popular. As it is now, cost neutral transformations of our delivered storage is going to be not very many GPUs. So the final slide is our current status. We have DP1 as Knut said. We are in the process of, we'll start ingesting DP2, and then they'll be accessed by the C2C tools as well as the Rubin data butler type thing. All the DR1 hardware, we were originally targeting a January 27 release date for DR1. So because of procurement lags, we started this process about 2 years ago. So all the stuff is either ordered or has arrived or is online. And if DR1 was suddenly to magically come back to January 27, we'd probably be on time for that. As it is now, we've deprioritized things slightly, but all this to say we will have a bunch of hardware fairly soon. And the only piece that's really missing is right now, if you want to add Rubin users, we have to do that onesie twosie one at a time, whereas we are looking at a general solution with any data rights holder would automatically have access to the resources we're providing to Rubin. So right now we have no Rubin users. We are looking for test users because Frosty tells us that LSST users are I won't repeat what she said, but she says they're odd, and we would like to have some experience with LSST users for DR1. So if you're interested in accessing our services, send us an email at support@camp4.net, and we can see what we can do.
Thanks, Stephen. I think we'll have questions at the end in the discussion. Almost really burning questions come up throughout, but next up is Denmark and Aman.
Hi, and good morning, everyone. Denmark. I'm Aman. I'm a PhD student, and I'm going to tell you a bit about what we're interested in and what we offer, and you can decide if our interests align or you'd make good use of our IDAC. So IDAC in Denmark, our main focus case is on transients and galaxy science and the intersection of the two. Just working with LSST alerts, looking at the innumerable amount of galaxies that LSST will discover, and also trying to analyze the host galaxies of these transients with the galaxy catalogs that come from LSST, along with a few other surveys that we'll see in the next few slides. We're also interested in adding some value to some of the LSST products. So we have target selection algorithms that can be run to understand which alerts can be spectroscopically followed up, depending on the metrics people have. And we also have an in-house fully Bayesian fast SED fitting tool that we're planning to try and use to get quick host properties for alerts to give them priority for follow-up and so on. And to this effort, we're involved in the DDP3 cross-cutting effort, where some of the allocation of our resources will be used on processing Euclid and Rubin together to provide photometry of deblended galaxies. And what do we offer to accompany all of this? We have mainly in Denmark been focused on getting performance. So we have about more than 1,000 CPUs that we use for managing the database, allocating to the users, and running the front end as well. Our main focus is also on hosting catalogs. We have more than enough space for the catalogs, but we can't really commit to hosting all the images that come from Rubin. So most of our data will be in the form of SQL-based databases that can be queried by the users. We also envision that most of the work that's going on in the IDAC will be done through simple code, just through submitting your Python or favorite language scripts to Slurm. And we have a Lustra file storage space, file system with a space of about 5 to 6 petabytes, which we'll use for both hosting the data as well as allocating to the users. We currently host, of course, the LSST data sets. We're also very interested in using Euclid catalogs as well to supplement them with infrared information. We have some auxiliary data sets in the form of 2MASS and Gaia, and we're working on getting SDSS and DAC up for good spectroscopic redshift analysis of Rubin alerts. So if you think that any of this sounds interesting and you want to get in touch, we'd encourage you to get in touch with us. For now, before DR1, we have to do this a bit manually because we're working with the University of Copenhagen high performing computing center as well. So for now, you contact us and we can contact them and try to get you an account. But by the time that DR1 comes around, we're planning to make this a bit more automatic where you authenticate against the Rubin Science platform and then can get an account at the HPC center. We also have these wiki pages that we are building at this point. And if you, again, want to get in touch, you can contact the leads listed here or come up to me and ask me anything during the conference. So get in touch. Thank you.
Thanks, Aman. Are those wiki pages linked to the dashboard?
We will eventually.
Okay, great. Thanks. So next up, George, are you online?
Yes, can you hear me okay?
Yes.
Excellent, great.
Okay,
Good
I'll
afternoon,
advance your
everybody.
slides for you.
Cool. There's only two, so it should be straightforward, but thank you, that's great. So good afternoon, everybody. My name is George Beckett. I am part of the UK in-kind contribution team, and I'm based here in Edinburgh. I'm sorry I couldn't be there at the meeting this time. This is a challenging time of year in Scotland because school holidays mean it's difficult to travel. And so I've actually not managed to get to any of the community workshops in person, but maybe next year, fingers crossed. So a quick update on the UK IDAC. Some of you will have heard this before, but hopefully there is some new information even for those people. So we are, as Knut said, planning to host a full IDAC. That means that we're planning to host complete data releases and to size our IDAC for around from 1,000 to around 1,500 data rights holders over the lifetime of the survey. As with Rubin's DAC, we are planning to have the two most recent data releases available to users. There is a transition period as we move from one data release to another. So the system is sized to hold two data releases in total, which means when we're ingesting a new data release, the older one is likely to disappear for a short period of time. But there will always be at least one data release, and most of the time there will be two. We're running as much of the Rubin software as possible. So we run the science platform, and if you visit our IDAC, you should see a very familiar interface with portal, notebook, and API support. And so it should be very easy to get up and running with our IDAC if you are familiar already with Rubin's own DAC. Some slight differences between our setup and the one in the US. First of all, we're co-located with the LASA community broker, which hopefully some of you are aware of. This is one of the community alert brokers. It's the UK one. It sits amazingly close to our DAC software services. And we have created currently some quite simple notebooks which show you how you can do analyses that span both the LASA data sets and LASA databases, as well as Rubin data products. And over time, we'll mature that and make that slicker and more functional. We also have several significant user-generated products planned for here in the UK. These are other in-kind contributions that we're making, and I've got some notes about those on the next slide. In terms of support, we are following this. Oh, sorry, I'm still on the first slide. I knew I was going to confuse you. I didn't mean to. In terms of support, we're following the same approach as Rubin, and we have a topic on the community forum, and you're welcome to ask questions or raise comments there. Some of our DAC team try to keep an eye on that, and with our colleagues in the community science team, we are aiming to be prompt in responding to questions as they arise and as use of the platform grows. Our setup is slightly similar to how Rubin have set up their IDAC. Ours is currently based entirely in an on-premises cloud. It runs on a system called OpenStack, which some of you will know about. And as with Stephen, we have been buying infrastructure to prepare for data release 1. Our cloud platform currently has 5,000 cores. Not all of those are user cores. Some of them run services and databases, but a fair proportion of those are available for user code. We have 6 petabytes of storage, much of that set aside for Rubin datasets, but we also host other datasets on behalf of other services, which many people will have access to as well. We are running the QServe database, which hopefully many of you are familiar with. Ours is not as big as Rubin's. It's a 15-node QServe, which is around, I think, a quarter of the size of the Rubin one, but it does have a large capacity, around 1.5 petabytes, which should be enough through until at least data release 1, and we will expand that over time. And we're on the UK's academic network, which is called Janet, and we have a 100 gigabit per second uplink directly into that, which means we are pretty well connected, and it should be relatively straightforward and efficient to stage significant data into our DAC, or if necessary, stage data out. And depending on your location, latency should generally be good. Slide 2, please. Thank you. Yes, so in terms of our current data holdings, we have a full copy of Data Preview 1. That includes both the initial Rubin release of products, catalogs and images, but also the LSDB team's HATS formats catalogs, which I'm sure many of you are aware of and are probably discussed elsewhere in the conference. And we are in the process of beginning to ingest Data Preview 2. We have some shiny disks waiting to receive the data. And in fact, we already have some of the HATS data available if you're a user on our system. Some of the user-generated products that we're expecting to support in the coming years. So we have an in-kind contribution, which is taking Rubin datasets and fusing them to near-infrared images from the Vista telescope, which in a sort of simplistic way expands the number of observed bands that you can extract information from for areas of the sky where Vista and LSST survey overlap, and I think that's quite a good overlap. We currently have our first production fused dataset, which is Vista and DP1, and some of you may have seen we've talked a little bit about that on the community forum already. We're also hosting a sophisticated cross-match service, which is intended to perform well in crowded fields. People keep telling me the whole of LSST is a crowded field because of how sensitive and performant the camera is and telescope is. But currently we have produced example cross matches for 2 pairs of hopefully interesting surveys, which is Gaia combined with either the Catwise survey or combined with the 2MASS survey, and they are both also available on our IDAC at the moment. We've got some tech previews in progress, which mean things that probably don't work or might work, but hopefully will mature over the coming months. The first thing we're doing is, because we're an on-prem cloud and we're definitely a finite size cloud, we're looking at supporting burst out capabilities. The primary driver for this was during periods of very high demand, maybe after a new data release has been produced or after some very exciting science has been discovered, we're expecting to not be able to serve every user that wishes to log into our platform. And so what we're doing is working with a commercial provider to allow us to spin up notebook instances on a commercial cloud, but routed back into our IDAC, a little bit how the hybrid model works for the Rubin DAC. That is meant to provide additional capacity at peak demand times, but actually our cloud provider has a number of different flavors of compute resource, including different GPU flavors, and we're hoping to make those available. So if you're interested in using GPUs with our platform, you'll be able to do that via this burst out capacity. The UK has had a reasonably significant investment in new digital research infrastructure in the moment. It's probably not at the scale of the United States, but people in Europe and other parts of the world will sort of recognize the level of investment we have. And we're creating tooling to allow integration of workflows with HPC resources and AI facilities around the UK, using this Janet backbone and our high bandwidth network, and providing tools based around things like Globus to allow you to stage data and workloads onto these resources. We don't provide you with the time on those resources. You have to apply through their access schemes. But if you have that capability through perhaps your science collaboration, this is a useful tooling to allow you to do that. And finally, one of the other services we host on the Somerville system, our cloud platform, is the Gaia data mining platform. And that's based around the Spark and the Dask frameworks, which are ideally suited to column-oriented data sets, such as the Parquet catalogs that Rubin has produced as part of each data release. And we're going to ingest the Parquet data into the Gaia data mining platform and make it directly accessible from the DAC, so that things like Spark and Dask-based queries and analysis workflows should be able to be done without a prioritized setup on the part of the user. So that's just a sample of some of the things we've got planned and where we're at. As our colleagues have said earlier, if you're interested in getting access to our IDAC, please reach out to me. We have a number of users on at the moment. We aren't yet integrated with Rubin's ID provider, but I'm hopeful within the next possibly as little as a few weeks, couple of weeks, we will be able to support that, which means you will log in with the same credentials that you log into the Rubin IDAC data.lsst.cloud. Thank you very much. Hopefully I didn't overrun my time.
Thank you. So next up is Brazil.
Yeah.
Carlos Avian.
Okay, I'm Carlos Adian. I'm from the Linea team responsible for the implementation of the IDAC Brazil. So before we explore the Brazilian IDAC, I'd like to briefly introduce. The Brazilian IDAC offers Rubin data, of course, as any other IDAC, scientific resources and computing capabilities that cover a broad range of scientific research. I will not focus on the hardware, but on the capabilities. Let me show you how you can interact with all of these resources. Let's start with the Brazilian IDAC Science Platform. Our science platform brings together a collection of tools and services used to support different science cases across the Rubin community. Let me highlight a few of these capabilities. For catalog exploration, user query provides an intuitive interface for SQL and QL queries with personal workspace through MindB, and it makes it easy to explore catalogs and build a data set for your science. In addition, for interactive analysis, Jupyter Hub offers a familiar notebook environment for data exploration, and you can use, for example, the tab serves, our tab serves, or maybe Rubin tab serves. On the visualization side, for image visualization, SkyViewer provides access to images from multiple surveys with catalog overlays for inspection and comparison. And finally, for detailed inspection of individual objects, Target Viewer brings the information needed to explore and validate potential targets in a single interface. Taken together, all of these applications provide complementary capabilities that support different research questions across the Rubin community. In addition to the science platform, the Brazilian IDAC also provides access to a collection of data resources. Here, users can discover data sets, the access methods, and science products and services. Let's start with the available data sets. The catalog includes Rubin data together with a growing collection of legacy surveys that can be used in a wide variety of science cases. For each data set, you also find the information about the available access options. And beyond the survey catalogs, you also find science products and services, including the PhotoZ server that Julia, my colleague, will talk in more detail on PhotoZ session on Friday. The prediction occultation database interface for solar system configuration, and local mirror of the minor planet center database that you can use through the user query interface. Each of these resources is fully documented online, and this is the best place to get started. docs.linea.org.br. Here you'll find user's guide, registration instructions, and all information about every available resource. And to make things easier, the documentation is available in English, Portuguese, and Spanish. And of course, if you ever need any kind of assistance, our service desk is available to help. And that's it.
Close. Yeah. Yeah, excellent. Jorge, are you online?
Yes, can you hear me?
Yes, we can hear you well. I'll
Okay.
advance your slides.
Okay, thank you.
Yeah.
So hello, everyone. I am Jorge Carretero, and I'm going to present the current status of the Spanish Light Independent Data Access Center, which is located at the Port Información Científica, PIC. Pau Tallada is also joining us online, and I hope he will answer and will be happy to answer any question. So here we can see the total resources available in our current infrastructure. It provides 200 CPU cores, half a petabyte of shared disk, and 8 GPUs. And in addition, we can take advantage of our shared Hadoop cluster, and you can see also in the slide the main characteristics in terms of numbers. And then regarding the services we provide for Rubin users, they can access Jupyter Labs, and you can see the characteristics of each of the sessions, so up to 32 gigabytes of RAM, 4 cores, and 2 GPUs. And there are several other additional applications, such as Virtual Studio Code or remote desktops. We also provide parallel computing, such as DAS clusters, as well as Spark. And what I think is interesting also, and I would like to, at least after this presentation, to have some users, is that you can directly come to our webpage and register, and then after registration, so you have an account at PIC, and then you request LSST IDAC access using the Rubin Science Portal credentials. It is currently working, and I believe, yeah, it should work. So once you have done that, you can access to this Jupyter Lab and also the batch processing using HT Condor. And finally, our kind of main characteristics, or I believe is our our main product, is CosmoHub. CosmoHub is a web portal which allows the users to access and explore very massive data sets, structured data sets. I think it is interesting to remark that we only provide access to catalog data, okay? No images. Also, you can register directly through the link in the slide, and you have to request LSST IDAC data rights. And in this case, it is still a manual approval for now, and we are currently working really hard trying to integrate both accounts and make the life of the users easier. Next slide, please, Nut. Okay, so, well, these are the main characteristics of CosmoHub, because I think it is interesting to know how it works. you can run any complex and large query. Even if the outputs are very large, it works pretty fast. Users can easily build their own custom catalogs, and we also provide several useful user-defined functions such as hill peaks, spherical geometry, or array aggregation. You can also explore and analyze the data using several histograms, 1D, 2D, and hill peaks. We have recently also integrated new plotting tools such as fan plot and correlation plot. We already have DP1 and other like DP02 and also previous simulated data from LSST, and we plan to ingest also DP2. And in the image, you can see something of one feature in Cosmo Hub, which we believe is very interesting, is it is called Canvas, where you can make multiple plots in the same space or workspace. And what I think is interesting is that you can share easily this analysis. So I put a link that you can download, and you can import in Cosmo Hub, and you directly see what I have been doing. You can see the queries that I have run, the plots, etc. And then you can extend or improve or modify this Canvas session. And then also you can share it again. So it's a very reproducible way of working. And then I think it is also interesting to mention that we will host, or we will be able to host value-added data and data products from any science collaborations, for instance, the Dark Energy Science collaboration. Next slide, please, Knut. Okay, so this is a bit of propaganda also, but what I believe is also interesting is that whenever you access Cosmo Hub, you not only access to LSST data, but you can access many other data sets, right? So we host a lot of different data sets from cosmology in particular, but also from other scientific branches. I'm not going to enter into details, but you can come here later and see the different experiments that we support. And then finally, next slide is something that we have recently developed, and it can be, I believe is also very interesting, is that we have developed a Spark notebook in Python with some PyWidgets where you can configure the job, and what it does is to do a custom cross-match between any data set in hosting in Cosmo Hub. So as you can see in the image, there are two boxes where you put two different SQL. So you do your both selections. In this case, you can see that is DP1, the DP1 object table with 2.3 million objects, and then in the target SQL, you can see the Gaia data release 3, and then you configure the number of neighbors and the maximum distance to which you want to do the cross-match, spacing cross-match, and this works in parallel in our Hadoop cluster, and this is an example that took less than 3 minutes. And yeah, and finally, we are also looking for LSST users. Whenever you come to our IDAC, you directly can use Jupyter notebooks, including Spark, and as well as Cosmo Hub. And I include here 3 different emails from myself, Pau Tallada, and Nacho Sevilla, if you want to contact us. Thank you very much.
Thank you, Jorge. So
Thank you.
next up is Agnieszka talking about the Polish IDAC.
Okay, so I'm going to be really fast. So this is this is supposed to be the status. My name is here because I'm the lead of the Polish program, but otherwise it's done by our highly skilled team. Those of you who were present at the LSST at Europe in Poznań last year could visit the supercomputing center in Poznań, where our IDAC is physically located. It belongs to our institute, but the supercomputing center belongs to many institutions actually. So this part is ours. And this is the most important slide here, which says that we have the IDAC already there. Physically, we have all the hardware that's supposed to be there according to the agreement, plus some extra because some extra may be necessary, especially that now everybody wants to have images, to have coads, and we expect that we will have them as well. So we have RSP installed and operational. We have the practically all the steps implemented and tested up to DP1. Now we will make next tests on DP2. The missing part, which is still under tests, not really missing, but under deployment, is QServe catalog database, and this is the demonstration that at least the platform can be found there. We have the identity check system hopefully fully implemented, so it looks like it works. Now we are performing tests based on the local user, but very soon we are going to gradually enlarge the pool of the users to see that all is under control. We have both RSP and the notebook developed there, so that users can use the database in different ways if they wish. Also, as a part of the next phase, one thing, as I mentioned, we are envisioning to expand the resources. How much it will depend on the funding and external conditions, but certainly necessary. Another part, this is the funding that our IT guys have got, and they are actually looking forward to develop it, is the public repository with some teaching programs and teaching algorithms implemented, which will be operational after the data will be after the proprietary period. So that's about it.
Thank you very much. So we're going to switch gears now. So we've heard from IDAC providers. We're going to start hearing about science use case pitches. And first up is Anuprita More from the Strong Lensing collaboration. There. Oh, do you have the clicker? I guess. Oh no, it's right here. Okay, thank you. Actually, the microphone is in there.
Yeah.
So, yeah. There is no microphone.
Okay, I'm just going to use this.
Yeah.
Okay. So hi everyone, I'm Anuprita More. I'm representing the Strong Lensing Science Collaboration, and I want to talk about some of the science use cases for the IDACs. So first, the one that I'm going to talk about This is an actual project that is happening right now, and we are getting the support from the Mexican IDAC. So the idea for this is image cutout server. So within the strong lensing, some of the various tasks that we're going to perform, like searching for strong lenses or modeling them or analyzing them for any projects, we can think of two basic domains. One is at the galaxy scales and the other is at the groups and cluster scales. So essentially all of the analysis that we would like to do happens at these two scales. And for most of these projects, we require multi-band co-add cutouts. And so we thought that if we could prepare these bespoke co-add cutouts at these two domains or that at these two scales, then these could be provided in this image cutout server, and then this can essentially serve the needs for most of the members in the SLSE. And so we decided to set up this image cutout server, which will host the multi-band co-add cutouts, which can then be used for searching for lenses or modeling or doing any other kind of analysis. The kind of data that we need are essentially like beginning with some catalogs of galaxies and AGNs and groups and clusters, with which we will start the selection and then generate these multi-band co-add cutouts. And we hope to do this prepare these cutouts for every subsequent DRs. And so the compute resources that are required for this is essentially long-term large storage of these cutouts. There's not a huge requirement on the processing. It's basically to just fetch a subset of the cutouts for different projects, and then transferring them to the local machines wherever the users are planning to use them for the different analysis. So this is an actual project which is happening, making use of the IDACs. Here I'm listing a few different other ideas which people have shown interest or expressed interest. However, these are not something that have been formalized yet because there hasn't been sufficient demand for a wider need identified as such in the collaboration. But these are potentially ideas where we would we would benefit from having resources from the IDAC. So starting with static lenses, where again we will make use of coads. So obviously with this image cutout server, that's where we will provide all the coads. But the kind of analysis, like for example, searching for lenses, we will have multiple teams who would like to then use those same coads for running their lens finding algorithms on those data, right? So some people have expressed the need that they would like to have access to GPUs and other data storage and so on for training their networks and testing and so on, and so that they can also even perform the lens searches directly on that data which is located in the IDAC. So if we could, if there is sufficient demand for this, then we could have resources set up on the IDAC where people could actually train and test their networks. They can actually directly perform their lens searches and also lens modeling. The same resource could also be used for generating simulated data, again, either for lens searches or for any other analysis. So that's one category. Then the other category is this is relevant both for static and for transient kind of lenses. This could be either working with coads or single visit images, and the kind of tasks or analysis which involves this is, for example, many of the lenses that we work with, they are at the scale of 1 arcsecond, and that's the sort of scale that that is affected by the size of the atmospheric scene. And having a good deep blending algorithm is very important for us to be able to find those lenses or even extract useful scientific parameters out of from the analysis of these lenses. And so we would be interested in running some deep blending algorithms on these data, which could be either working with coads or single visit images. And then this can be useful for certain science. And then similarly, There's also interest in, there could be certain science projects which could benefit from analysis of just the best or optimal seeing co-added exposures rather than everything that is that exists for a given footprint. And so this is also something that is like a custom sort of analysis and would require another set of resources, which we could have, set up on one of these IDACs. So these are like various ideas, and some of these can be useful, beneficial, but we are yet to, set up this as some formal projects. And depending on, what sort of access we have and whether we have also appropriate manpower for working on these projects, then we could, think of actually proceeding with some of the, setting up some of these projects officially. So that's all.
Thank you. Let's see. Our next pitch is Meg Schwam. Meg, are you online?
Yeah, can you hear me?
Yes, we can hear you. Just tell me when to advance the slides.
I think I only have one.
Okay, yeah. Good. All right.
So hopefully that helps. Okay, so I'm Meg Schwam. I'm co-chair of the Solar System Science Collaboration. So I think mainly the one thing or at least the one thing I could see that we need coming soon would be people want to do faint commentary activity searches. We really can't do a lot of this with the cutouts. We need bigger cutouts than that. I imagine with machine learning training, we don't want to be re-downloading the set every time one of us wants to go do our thing, because everyone will have their own algorithm. Because Rubin will find much more faint commentary activity than we've seen before, just because it's a bigger light bucket. So it would help if there's somewhere that we could store these. I think it's a problem across all the science collaborations that if you're doing machine learning training, where do you put your training sets and how do we get them over? So I can see that this is something that maybe where an IDAC can help. Again, also with AI development, people are going to want CPUs and GPU usage. Again, one of the reasons why we were interested in working with Burr. We don't have an estimate of resources. We have no idea how much people want to do, partly because we don't have enough data in DP1 to be useful, and the cutouts within what's currently available in the alerts isn't useful. So we need DP2, real DP2, all of DP2, to be able to even start answering this question. So I don't know how that impacts things right now, is that we're waiting for the real image data for us to be able to start looking, even applying this on the very small number of comments that might be in the DB2 data set. I just want to highlight that Aspen Institute has proposed a service that can help with some of this. If people are only caring about getting a certain object and getting cutouts to do some analysis instead of doing bulk training, that's something they're interested in helping with, that would make it easier to get cutouts. But they do require OIDC client pre-registration, but they're not currently part of the set of IDACs. But I think that's kind of for probably smaller use cases. People that want to run machine learning algorithms are going to want to have the compute next to the data. And I think that's something that I think cross-science collaborations would be really helpful if there were IDACs that were fully set up for that. Or we're advertising that, because I think a lot of us aren't fully aware whether this capability will be available. So that's me.
Thank you for that. Maybe just one question for clarification. So are you looking for IDACs to host visit images or to host image cutouts that would be produced?
Cutouts.
Yeah.
Much bigger cutouts than what you get in alerts. Because the whole visit image isn't useful to us, right? So you're going to want to take the cutouts and throw them through your machine learning algorithm. And so I can just imagine right now, every Comet person who wants to do analysis is going to download a good chunk of them. Or you want to actually look for faint activity across all solar system objects. And so you're going, we're all made but off 5 million asteroids. And so you're going to want that. And I think it's silly to be having people just constantly downloading that.
Yeah, good. Thank you. So we have a contribution from TBS put together by Igor Andrioni. Yes, he had to be in a parallel session, so I'm going to briefly speak to this. For TBS, I think a big part of their use case is photometric classification, right? So classifying things that change, and as part of that, estimating parameters for models that fit various kinds of transients and light curves. Related to this, for variable stars, a period computation is computationally expensive. And also with these light curves, you can find things that are strange, anomalies in the transient and variable sky. And sometimes this depends on being able to pull in data from other surveys other than Rubin for context, including images. And I think Igor stressed that you don't necessarily need visit images or visit image cutouts for this, but simply having a cutout from a COAD gives you contextual information to produce these. But the key data set is clearly the DIA object table and the time series to be able to do these computations. So that was that. And then Agnieszka, you want to speak to this?
I can speak to this.
Okay.
So the concept of this slide was not necessarily to list all possible science cases for our IDAC, because we have many more of them. The idea was to say what we use now for science cases to test our IDAC, our RSP, and apparently we can do it. So such exemplary tests are codes to perform pipeline, building a pipeline to perform aperture photometry. It was done on the DP1 data to use them as auxiliary data for the analysis of the JWST data. So things like that are possible. Search and identification of low surface brightness galaxies or any other specific type of galaxies using, in this case, combination of statistical techniques, means extractor, Galfit, and so on, but also placing directly new machine learning algorithms for detecting specific features or specific types of objects. So these types of science cases are tested, but more will be possible, and hopefully we can do it together.
Thank you. Okay, that was it for the presentations, the pitches for IDACs and science use cases. So for the rest of the time, we have 25 minutes or so. I'd like to get some idea of how do we get this pairing between IDACs providing the computing resources and the science community doing the science, get this to work as smoothly as possible. So my first prompt is there anything else that science users in the audience, online, or in the room feel like they need to know about IDACs before they can really start plowing ahead and trying to make use of these resources?
Don't the overhead mics work?
Apparently not. I mean, it works right at the podium, but not here.
This is Bob Blum. I just had some trivial questions based on the presentations made that I just wanted clarification for. So, Stephen, you said the Canadian IDAC had a copy of the Rubin Science Portal. Is that just the same as the portal aspect? No.
Oh, the Rubin Science Portal, that's right. Yeah, we have a copy of the Firefly. Oh. We have a copy of the Firefly part of the RSP. Everything else is our own homegrown thing, which we think is better. But we also think the Firefly portion of the RSP is better than anything we have, so we adopted that.
George Beckett, if you're still online, I was curious regards to the Vista Fusion work, if and I don't even know if this question makes sense, but will the fusion happen with each data release, or once DR1 is done, that will be the last fusion?
The plan is to fuse for each data release. I suspect possibly by year 5, year 6, Vista may not be the ideal thing to fuse against. It may be that we've switched to a different infrared survey, but a definitive answer we should ask the people doing the work, because I'm not actually an astronomer, but I am confident they're planning to do this for the first few data releases at least.
Thank you. Thank you for that answer.
Yeah, yes, Bob, thanks you for that answer.
So I think we can hear the overhead mics, in that I can hear other people even when they don't have the mic.
Oh, good.
It's
Did you hear
not
Bob
quite
say
as
that?
clear. Yeah, I heard Bob. It's not as clear as with the mic, but it is certainly for me, it's audible.
Okay, excellent. That's good to know. Yeah. Anyone else want to comment on the prompt? What more do you need to know about IDACs? I can pick on people if if you want me to. Yes.
I think they can hear us.
Yeah, yeah.
You actually said that there'll be an annual science-based review of resource usage. So is Ruben in the middle on this, or how do people indicate to you how much they're using? Do the IDACs report to you? I'm not sure how that is envisioned, and what's the cadence? Is it January? Is it June?
Good question. So this is just as a result of this agreement between the Solar System Science Collaboration and one particular IDAC. So the model for evaluating these agreements is something that we would conduct on roughly an annual basis, and I think it would coincide with the annual review of the in-kind program itself, which is something that we do as the in-kind team. That does have a written down schedule, which we have never adhered to. So yeah, we have some work to do there on making sure that it happens when it's supposed to. But the idea would be for the users, the Solar System Science Collaboration, who are getting this resource as part of this agreement, to provide a description, basically of how they use the resource on an annual basis, timed with the annual evaluation. Do you want to speak?
I guess the overhead mics work well.
Yeah.
This is Bob again. My view of this whole thing is that we will certainly be watching how these agreements and the use of these resources go, and we'll be looking for various, maybe non-completely formal indicators that it makes, that it's actually providing scientific impact. I actually think we've already seen the Solar System Science group do good things with compute resources that we made available, and they're very incentivized and energetic about making progress. So I don't have any real concern that they won't do that, but we'll just be watching and looking and talking and making sure that we think the resources are being effective. So we'll definitely connect with folks, and we'll expect to hear about results at meetings and things like that as well. I just want to say, I think this is a really good aspect of the in-kind resources and the IDAC's contribution, because it's a broad, we've tried to be really open to taking on folks that have resources and want to make them available. But that results naturally in a kind of heterogeneous set of things. And if all we did was say, well, we're going to run some kind of call for resource use every year, I think it would be really cumbersome and hard for users to interact. So what we're trying to do is really incentivize science collaboration specifically because of their organization, because of their focused science goals, to see this as an opportunity, spend a little time looking around and thinking, is there some need we have that if we had dedicated time and support from a group, we could make really good use of it. And, if we get to the point where it's so good that the collaborations start, I don't say this in any negative way, fighting over the resource, that would actually be a good outcome. And then we'd go from there and figure out what to do next. But I really want to make sure that someone somewhere in the overall Rubin science sphere is using those resources that have been made.
Thank you.
Go ahead, Greg.
We've heard from one IDAC about this sort of look and feel of the front end of it. It's supposed to be very much like Firefox, Firefly. Is there any chance that it could potentially have maybe some kind of fair of display of how do different IDACs look like? How does it feel to interact with it? Because there might be some aspect of different IDACs that maybe are more appropriate to your science cases. So I just wonder if that's the kind of thing that we should think about. Just learn the lesson from some of the developers.
Yeah, I think that's a great idea. Having a fair, as you say, sort of a demo, especially now that IDACs are really getting to the stage where they can provide one, and maybe even as paired with a hack session for users where they could start trying it out for their science. I think that could be a way to sort of juice the usage. Yeah.
That's kind of like, this gets done for the brokers, right? Like how do the different brokers work? How do you interface with them? So I think the same thing would be quite useful here.
Yeah. Excellent suggestion.
Plus one to that. The idea of, as I was saying earlier, right now, when we get the full resources, like you say, ask the same question a year where you have all the DR1 resources basically in place, then inviting 50 Rubin users on all at once would be fine. Right now, it would be kind of a bit awkward. We'd perfectly have to give a demo, but a tutorial would be a little bit more, I think, with hands-on actual uses would be more challenging. At the time with DR1, it'd be, totally manageable. But definitely a longer, there's a limit to how much each of us can present in 5 minutes, even just slides. And I actually kind of want to see all the other IDACs and see what they're doing to see if there's something that we want to adopt. So some sort of session, sort of after everybody's got DP2 ingested, some sort of online session or in-person session 6 months from now, I think would be super useful.
Yeah. Good.
It's gone for this round, but can I suggest the Discovery Alliance workshop calls as possibility for organizing such a thing?
Yeah, good idea.
Workshop.
Yeah.
Well, they just had a round of proposals, so around DP2. I don't know. Maybe next year. I don't know when the next call will be, but that's just a thing to look for. There are Discovery Alliance calls to support, actual work and workshops. So yeah. So maybe a year from now.
Yes. Yeah, that would be excellent. Yeah. Yeah. Good.
I have a question. How soon will the data be available for IDACs?
Yeah, so DP1 is available in several now. DP2 transfers. Maybe Sierra can chime in here. Yes.
We are actively working on it. We're hoping to have it out in the coming weeks. So it shouldn't. I don't think it's a timescale of a month away, but there's still some last steps to work out on our end. And then that data should be transferred by Ruscio first, and then we'll probably see if there's anything else we need to do for people who are lagging behind.
Yeah. So the idea with DR1 is to try to get as close to releasing at the same time as through the US Data Access Center as possible. It's a challenge because of, the data volume is quite large, and moving it around is challenging, but that is the ambition. Yeah.
I think this EDB2 is maybe a bit unique in that it was really a sprint to get it out in the RSP. And there was even some of that sprint happening right up until Monday. And so now that that's happened, we're the downstream work of gathering it up to do form distributed to IDACs. But possibly even, I don't want to overpromise, but possibly even for full DP2, we might be able to be somewhat more synchronous when it gets staged.
Yeah, that'd be great. Yeah.
If it helps ease anyone's worries, this is like our 8:30 mornings right now. We have 8:30 meetings to sort out getting this sorted. It's very much on our radar to get done soon.
Yeah, cool.
Yeah. Is EDP2 actually going out right now or not quite to the IDACs?
Not presently.
Sort of the definitive version of it is actually defined within the cloud-based RSP deployment. And so we have to re-engineer or import it back to a USDF version that's matched to what's available in the cloud RSP, and then make sure we're shipping out a consistent version.
Yeah, cool.
Do we envision any kind of syncing necessary after the release of such a thing? I can't think of what it would be, but if some reason we change something on DP2, then we'd have to sync all the IDACs too, or it works DR1.
Historically, we had that happen with DP1. There was a version change after we shipped it out to the IDACs. The good news is it seems that all we need to do is update the files in Russia, and essentially it will reship itself as long as we build back up the link.
Okay.
So worst case scenario, if something were to change that we needed to ship to the IDACs, I think it would basically just be the same process. It wouldn't need to have something very separate.
Yeah. Nevin, go ahead.
Yeah, it's a shameless advertisement. If you want the HATS catalogs that, for instance, George mentioned and Brazilian IDAC mentioned, you can get those. And I posted instructions in the Slack channel, which IDAC coordination channel, and that can be pulled. And I think even today Brazil pulled it in 4 hours. And it's only catalogs, but that should work.
And we're planning to have it as well. I just didn't have space in my slides, Nevin.
Yeah. Excellent. Yeah. Any more comments online on this topic or in the room? Yeah, we sort of covered. I mean, I really like the suggestion of something more interactive, demo, a hack session, and to get people talking to each other. But for the IDAC providers in the room, I guess, what are the questions you might be asking of users in order to get a better idea of what they're trying to do? Is the stuff that was presented here today, was that enough to get to at least say that, yeah, this might be possible, let's talk, or is there clearly missing information that people need? Go ahead, Stephen.
I have 2 questions actually. So one of the things on my slides was the fact that we need to potentially change the mix of hardware offerings based on the fact that the coads are much smaller than originally planned. And we're going to put together a proposal to Ruben to see what could be changed. There's not a lot of flexibility, but if people have input, I'm extremely interested in hearing from people. Obviously, the answer is more GPUs, which is your last bullet point. But the exchange rate is just so bad between the storage that we've promised and the GPUs that we would like to deliver, that if you have a better suggestion or a cheaper suggestion or something that has more impactful, I guess, that would be interesting. The second question is like super specific to Meg, if she's still online. But when people say cutouts, are we talking about cutouts of everything in the visit images, which gets pretty heavy? Or is it cutouts of a very small subset of images of objects in the visit images? Or what? And I guess that was both Meg and yeah. There were two requests for cutouts, and just sort of more details on that would be useful in being able to respond to the question.
Right. I think Meg may have signed off. It's quite late in Europe.
I heard her say solar system objects, right? So
Yeah.
that's definitely a subset. You can decide whether it's
And
big
that's
or little.
minuscule in terms of data volumes.
Well, the solar system is right. So there's a solar system catalog, but I think what she was looking for was cutouts around solar system objects from the visit images, right? Yeah.
That's quite small.
Yeah.
Right. Yeah.
Mhm. Okay.
For comments, so they're a little bit bigger.
Yeah.
No, but the total data volume, most things in the sky aren't comets.
Right. Anaprita, did you want to comment on the type of in your science use case? Were they of the coads? Yeah. Mm-hmm. Okay. Yeah. George?
Yes, coming back to your question as to whether there is enough information, I think the format today has been really good, and I think it's been a great start. But it needs something to follow on from this, a next step, and an idea I've just had, which may or may not work, based on a little bit what we were talking about earlier, is whether some of the community science team could actually get accounts on the different IDACs so that they get familiar with some of the functionalities. They have the astronomy background, which potentially can help to make that tentative first link between a science collaborations use case and a potential IDAC or SPC that could support that use case.
Yeah, I think it's a good suggestion, worth considering. I want to be mindful. So the community science team, of course, they have responsibilities.
Sure, understood.
The U.S. Data Access Center and users of it, but it may be possible to have some targeted, especially if we had a workshop, right? Virtual or in person, where we could try out some of these things. Mm-hmm.
This is Bob.
Yeah.
I 100% with, I think it's a great suggestion from George, and I agree with Knut's answer. And I could imagine that some level of more than just notional familiarity with the IDACs could help the CST, because who knows what's going to happen when we turn everything on, and there's a lot of impact on the US DAC. It may be that they'll be able to say, hey, you're trying to do this thing. It might be you could get a little bit more mileage if you went here and did this or something. So it's not completely removed from their stewardship of what's happening at the US DAC.
Mm-hmm. Go ahead, Stephen.
Yeah.
Go ahead, George.
No, I was just going to say I'm totally sensitive to the workload of the community science team, and I'm certainly not trying to add to that. But it's possible something we could factor in. I know the UK has a small community science team contribution, and hopefully we could help with that too.
Yeah.
I think, sorry, I forgot what I was going to say. Sorry, I'm having a senior moment here.
Take your time. Since we're at sort of 5 minutes till, wanted to also introduce the last bullet point. I mean, so in 2023, we had a virtual workshop where many of the science collaborations contributed a set of 40 use cases. It put quite a lot of work into those, and we have used those to get some idea of how to how to sort of develop the IDAC ecosystem to support the users. But that was now 3 years ago. And at the time, machine learning and use of GPUs was, of course, present, but it wasn't, quite as entrenched and hot a topic as it is now. And GPUs are, of course, very expensive. It's a big investment. But one of the key things for using GPUs is knowing really what data sets are critical to have co-located with them in order for them to have sort of optimal value. And my assumption has been that co-added images and the object catalog, maybe the source catalog for the time series, would cover a lot of use cases. Is that a correct assumption or not? Do you have counterexamples?
So my comment immediately is almost none of the IDACs except for the UK are actually going to have visit images. So it'll have to be cover all the cases from the IDAC perspective.
Yeah. And I guess from our perspective, or my perspective, is if we encourage or try to incentivize IDACs to provide GPUs in return for a fair compensation and PIs with data rights, what value do they have if the only data product being hosted there is an object catalog? Yeah, go ahead.
So it's maybe just to open up the design space a little more. You wouldn't necessarily need, if you did need other image data products there, you wouldn't necessarily need to host them there long term. You can imagine staging them there. You can imagine streaming them depending on the rate with which they're being consumed. And I think some of this hinges on like technical details of like actually how fast can you pull things off storage versus what kind of network connectivity do you have and where might they be coming from. So probably other ways to take advantage of GPUs, even if they don't have a sort of permanently co-added copy of the
One thing we discussed in the CDC was, suppose we had a bunch of GPUs and with all that extra storage we have, we hosted, some buffer of the recent visit images, if there was some way that they could be, streamed to us. I didn't mention it because it's technically quite difficult. I think if it messes around with operations, we don't want to impose extra load, but it's something that could be potentially quite high.
Don't we want to try and work with folks to develop more focused data sets than just PPIs, like specific large cutouts that then could be more easily used in these cases?
I think they're per use case. So for instance, for Meg's comment use case, right? If you have a known sample of objects that you'd like to have that you think might be comets, and you want to look for activity on them, and their orbits, right? That gives you a subset of the sky in which you would need to get visit image cutouts.
Let me rephrase my question. Why is a set of PVIs good for GPUs? Don't you want to know something more focused before you just launch on all the PVIs?
But my sense is that a lot of machine learning algorithms train on image data, right? Because there's a lot of information in the images, but it can also be, from catalog measurements of those images. But I don't know if others want
the image part, but we just want to feed them all the images and let them go. Is that what we're saying?
Feeding a set of cutouts, I think, of images, not the full thing. But
you can imagine cutouts of the same field observed over time. maybe it's a large.
Sure,
field,
no,
maybe it's a small field.
I get the cutout part. I just thought we were talking about somehow needing to have all the PBIs in some place.
Yeah, I guess that was a question that is, if you need to produce the cutouts on the fly quickly, right, then do you need to have all the images there? But yeah. Anyway, yeah, go ahead.
There is another potential application for GPUs. We have a very experimental project. In the moment, we have just purchased a small workstation NVIDIA GB10 with support of the NVIDIA offices in Brazil to provide user support based on agentic AI for user support. So the idea is to have a model that can learn from the documentation and the data structure to help the users to interact with the data for data mining or to write powerful queries for discovery and etc. Something that we are trying to. The guy in charge is Rodrigo Buffler, and if someone has any question about this, I can share his contacts.
Yeah. Okay. Yeah. Thanks for that. That sounds very interesting. Yeah. So we're past the session limit, so I want to thank all the contributors again. And thank you all for sticking around until the end. Yes. Okay.
Thank you.